Hello everyone. This is my second uh, revision class. See, so till now we studied what is a group, right? Definition of a group. So in a group, the identity element is unique. It means if E1 and E2, if there exist two identity elements, if I am saying there exist two identity elements, then they are actually equal. Okay. So what is the proof? First take E1 is the identity of the group. So if E1 is the identity, then E2 star E1 and E1 star E2 is equals to E2 because E1 is the identity element now. Similarly, if E2 is, since E2 is the identity element, so E1 star E2 and E2 star E1 is equals to E1 because here in the second case I take E2 is identity. Okay. But what is this? This is the image of this element, right? So since star is a binary operation, the image must be same. So E1 and E2 both are equal. Okay. So that's why identity element is always unique in a group. Now, cancellation law holds in a group. What is the meaning of cancellation law? See, uh, see this equation. Okay, so you can cancel C like this, but how? It means A into C. If A into C is equals to B into C, it will imply A is equals to B. So this cancellation law called right cancellation law because we cancel C from the right side. Okay. Similarly, in the next equation, we cancel C from the left hand from the left side. So this cancellation law is called the left cancellation law. The proof is very easy. If AC is equals to BC, you can operate C inverse in the both side, right? Then apply associative property. Okay. So after applying associative property, C into C inverse means identity. Again, C into C inverse means identity. Then we have A into identity is equals to B into identity. And since E is the identity element, so A into identity means A and B into identity means B. So AC is equals to BC. From this equation, we have A is equals to B. Similarly, you can prove the second part also. Okay. Now, sock and shoes property. What is the sock and shoes property? AB inverse is equals to B inverse A inverse. So what do you want? You want to find the inverse of AB, right? What is the inverse of AB? Okay. So if I am saying this is the hint here, the hint is inverse of AB is B inverse A inverse. Okay. So just show AB into this element, AB into this element is equals to identity, and this element into AB is also identity. It will imply the inverse of AB is B inverse A inverse. How? So just this is the application of associative property. So first apply associative property, then B into B inverse means identity. Use the property of identity. A into identity means A, right? Into A inverse, it will imply A into A inverse means identity. Done. Similarly for the next part. Okay. So what is the inverse of AB? The inverse of AB is B inverse into A inverse. Here B inverse star A inverse. It means the binary operation on G. So, Sanjalidi, I am asking you, what is the inverse of this element?
A5 inverse, A4 inverse, A3 inverse, A2 inverse, A1 inverse.
So, see, the property is called Shock-Schuss property, right? So, when we were, first we were shocks, right? Then shoe. But uh, how we will remove? First we remove shoe, then shock, right? So that's why this kind of name. Now, so we are discussing about some properties of group. So in a group, identity is unique. In a group, cancellation law holds. In a group, AB inverse is equals to B inverse A inverse. Acha. In a group, if A is an element of G, then the inverse of A, this is also unique. Can you prove it? The inverse of an element is always unique. Okay. Can you prove it? Anyone? Ishika, can you prove it? I am asking, let G star be a group and A belongs to G, then the inverse of A is unique. That is, if B and C are two inverse of A, then B is equals to C. Anyone? Since
B inverse
B
equal to C inverse দেখালে হবে?
Since B is inverse of A, then AB is equals to BA is equals to identity. This is the identity element, okay? Identity element of the group. Since C is the inverse of A, then AC is equals to CA is equals to identity. Okay. So now observe AB is equals to AC. AB is equals to AC is equals to identity. And similarly, BA is equals to CA is equals to identity. Right? Now this is the hint. Already we have cancellation law, right? So by the help of left cancellation law, you will get P is equals to C. And from this, by the help of right cancellation law, B is equals to C. Okay, done. So in a group, identity is unique, cancellation law holds. What is the inverse of AB? B inverse A inverse. Now there is a question. A group is said to be abelian if AB is equals to B, right? This is true for all AB. So now observe, if the group is abelian, there is a question, then AB inverse is equals to A inverse B inverse. Is it true or false? So this part is very easy. Why? Because G is abelian, then from AB inverse we have, by the help of Shoksu property, B inverse is B inverse into A inverse. But since the group is abelian, then we can commute these two elements. So this part is done. What about the converse part? So for the converse part, we need to prove AB is equals to BA. This is true for all AB, right? So, so we have AB inverse is equals to B inverse A inverse, right? By Shoksu property. But here given AB inverse is equals to A inverse B inverse. So we have B inverse A inverse is equals to A inverse B inverse. Now take inverses in the both side. Okay. So if you take inverse in the both side, we will get, use again Shoksu property, then we will get A inverse its inverse and B A inverse its inverse into B inverse its inverse. Right? And from here, I will get B inverse its inverse and A inverse its inverse. Okay. So in the left side, I will get A inverse its inverse means, it means the inverse of A inverse. What is the inverse of A inverse? A itself, right? So A, here B, and again here B, here A, right? So we are done. So the question is, why the inverse of A inverse is A? Anyone? Can you explain why the inverse of A inverse is A? Because treat A inverse, say A inverse is B. So now actually I want to know what is the inverse of B, right? This is my actual question. But I know A star A inverse is equals to A inverse star A is equals to identity, right? So A star B is equals to B star A is equals to identity, right? Because I take A inverse is equals to B. So now from this equation, I am asking what is the inverse of B? So you can observe it, B inverse is A, right? And what is B? B is A inverse. So the inverse of A inverse is A. Okay, done. Now there is some notations. What is the meaning of A to the power K? A to the power K means A star A star A. How many copies? K copies. Okay. If K belongs to natural number. If K is some negative integer, it means A to the power K means A. If K is some negative integer, then I can write K is equals to some minus M, where M is greater than 0. So I am asking, what is the meaning of A to the power minus M? It means A inverse to the power M. And we know A to the power K means A into A into A, K copies. So it means A inverse into A inverse into A inverse, M times. Okay. So this is just a notation. You need to understand here the operation is star. If the operation is multiplication, so replace star by dot. If the operation is addition, then replace star by plus. Okay. What is the meaning of A to the power 0? It means identity. So if I am asking A cube, it means A star A star A. Okay. If I am asking A to the power minus 3, it means A inverse star A inverse star A inverse. Okay, done. So there, this is a property for an abelian group. Here, this is an property, again, this is an property of abelian group. So AB square means A square into B square. How? This proof is also very easy. So this part is, this is very easy. How? Since G is abelian, I want to prove AB square is equals to A square into B square, right? Into, here I am telling into, but you need to understand what is the meaning. It means A star A square means A star A, star B star B. Okay. I will not tell it every time. Okay. So start from this. AB square means AB into AB. Now use associative property. A into BA, A into BA into B. So since the group is abelian, so AB is equals, sorry, BA is equals to AB. So again use associative property. So A square is equals to B square. Done. But what about the converse part? So for the converse part, I want to prove AB is equals to BA. This is true for all AB belongs to G. I want to prove G is abelian, na? So if G is actually I want to prove AB is equals to BA, true for all AB. So take any two arbitrary elements, A and B. So here given AB square is equals to A square into B square. It will imply AB into AB from the left side. AB square means AB into AB, na? And for the right side, I can write A square means A into A and B square means B into B. Now use cancellation law, both left and right. So if you apply left cancellation law and right cancellation law, both, then we have BA is equals to AB. Done. Easy, no? So if G is abelian, then AB inverse is equals to A inverse B inverse. Actually, the following I am saying, The following are equivalent. First, G is abelian. Second, AB inverse is equals to A inverse, B inverse. Third, AB square is equals to A square, B square. Fourth, AB to the power n is equals to A to the power n, B to the power n. This is true for any three consecutive natural numbers or positive integers. Okay. These four property are equivalent. If you are saying G is abelian, then these three holds. If you are saying AB inverse is equals to A inverse B inverse, then G is abelian, then AB square is equals to A square B square, then AB to the power n is equals to A to the power n B to the power n. This is a nice question, huh? It's a calculative question. Okay. Now, here, is it true? Is it true for abelian group? Yes, for abelian group, this holds. But if, see, AB square is equals to A square B square, if this is true for all AB, then it will imply G is abelian now. Then G is abelian, right? So can we say this is for if you take 3, then is it abelian? So actually the question is, if AB cube is equals to A cube B cube, then can we say G is abelian? So no, the answer is no. Why? What is the problem? Because observe, AB cube means this. Now, and A cube B cube means A into A into A, B into B into B. So after applying cancellation law, what we have? We have this line, right? B A B A. Okay, and here A square into B square. So from here, can you say AB is equals to BA? Is there any process? Or can you say from this line to this line? So first of all, try this. If you face some problem, then go for the counter example. So there is a counter example. This is a very good example. Heisenberg group. Till now, we learn lots of examples of abelian group, right? R plus, Z plus, Q plus, R plus, C plus. Okay. Then R star dot, C star dot. Okay. Zn addition modulo n, Un multiplication modulo n. Okay. So all the groups are abelian groups, and there is a famous example. Power set of x with respect to symmetric difference. This is also an abelian group, and for this group, one thing you have to remember: every element, if you take A belongs to power set of x, then A symmetric difference A, this is equals to the identity element. Can you say what is the identity element of this group? Anyone? Can you recall? Empty set, na? Okay. So for this group, every element is self-inverse. If I am asking what is the inverse of A, the inverse of A is A itself. Okay. So till now we have lots of examples of abelian group. So the last lecture there is we learned the first non-abelian group. What is the first non-abelian group? We have learned GLNR, right? GLNR if n is greater than equals to 2 with respect to matrix multiplication. This is a group which is not abelian. Now I am giving you another non-abelian group, example of an non-abelian group. What is this example? This group is called Heisenberg group. So what is Heisenberg group? It's a very important example. Okay. So see, in this group, this kind of matrices belongs to in this group where A, B, C belongs to Z3. So you can take any ZP here, but if P is equals to 3, then the group is called Heisenberg group. Okay, but you can take any P. But to solve this question, I think you need to take P is equals to 3. So I am asking how many elements are there? Anyone? How many elements are there in G? Anyone? What are the unknowns? Unknowns are A, B, and C. No. So A has 3 choices because what is Z3? Z3 is 0, 1, 2. So A has 3 choices, B has 3 choices, and C has 3 choices. And all the choices are independent, right? So if the choices are independent, then we will multiply 3 into 3 into 3, right? So the order of G is 27. For this group, AB cube is equals to A cube B cube. So in this example, first I calculate this in a long way, but after that I did it by the help of linear algebra. So in this lecture, I will only discuss the second part, how to use linear algebra here. Okay. So Sanchalidi, linear algebra, it will be okay now? Okay. So, so observe in this group, D cube is equals to identity. How? So first I write D, then I calculate what is D cube. So D cube is this. So I want to find D square. I want to find D cube. So D cube means D square into D. So this is a lengthy process. So in Z3, 3 is equals to 0. So I write 0 here in the 1, 2 position. In the 1, 3 position, here 3B means 0. And here 3AC, it means also 0. And here 3C, this is also 0 because in Z3, 3 is equals to 0, right? So D cube is equals to identity for all D belongs to this Heisenberg group. So, so AB cube, what is AB cube? AB means some D, na? A into B, its cube is equals to, this is some D, this is a matrix. So this is equals to identity. And if you if you find A cube into B cube, so A cube is also identity, B cube is also identity. Identity means identity. So left side and right side both are equal. So this property holds. This property holds. But is the group is abelian? The answer is no. Why? Because I multiply this A and this B, then I observe this kind of then I observe AB is equals to this. Okay. And if we multiply B into A, then I get this matrix. But observe here, this part are equal, right? This is also equal. When two matrices are equal, what is the definition? When two matrices are equal, if the order are same, if I am saying A is equals to B, then first we need to check what is the order of A and what is the order of B. First need to show the order of A and B are same. So here the order is 3 by 3. Here the order is 3 by 3. Now observe, then we need to check the corresponding entries also same. So here 1 is 1, here also 1 is 1, here 1 is 1. Okay, 0, here also 0, 0, 0, 0, 0. Here A1 into A2, A1 plus A2, here also A1 plus A2. Here C1 plus C2, here also C1 plus C2. But here observe B1 plus B2, but here A1 plus C2 and here A2 plus C1. So choose A1, C1, A2, C2 in this way such that I will get in the 1, 3 position some distinct entries, right? So then AB, this will not equals to BA. You can choose na A1, A2, C1, C2 in such a way such that B1 plus A1, C2 plus B2 means this entry, and B1 plus A2, C1 plus B2. This is not equal. So actually I need, if you see, these two elements will cancel. I need A1 C2 and A2 C1. Actually I need A1 A2 C1 and C2 such that A1 C2 not equals to A2 C1, right? You can choose. So choose A2 is equals to 0. Okay, and A1 is equals to 1, C2 is also equals to 1. Done. Okay, very easy na. So this group is not abelian. Right. Now how dq is equals to identity? So this is calculative, but here I did it by the help of linear algebra. How? So observe D is this matrix. So you can write this matrix I plus A. What is A? I means identity matrix, and A is this matrix. Actually, A is a nilpotent matrix, right? Why? Because this is a lower triangular matrix. Okay. Actually, this is a triangular matrix. Maybe lower, it may be upper. So all the and all the diagonal entries are 0. So if a matrix has all the diagonal entries 0, then the matrix is said to be nilpotent matrix because all the eigenvalues are 0. So here in this example, A has all the eigenvalues of A is 0. So what is the eigenvalue of D? So the actually this is a polynomial of A, right? This is a polynomial of A, na? So take px is equals to 1 plus x. So this is a d p of d is equals to, sorry, d is equals to p of A, right? So what is the eigenvalue of D? The eigenvalue of D is 1 plus 0, 1 plus 0 plus 1 plus 0, right? So what is the characteristic equation of D? The characteristic equation is x minus 1 into x minus 1 into x minus 1, because this is a 3 by 3 matrix and we know all the eigenvalues. So x minus 1 its cube. So now D minus, and by Cayley-Hamilton theorem, since this is the characteristic equation, so Cayley-Hamilton theorem says the matrix satisfies the characteristic equation. It means D minus I its cube is equals to 0. Now apply the formula. Can you apply the formula? A minus B its cube. Can you apply here for matrices? Anyone? Ishika? What is the formula? The formula is this, right?
C square B plus AB square plus B cube or minus B cube.
Is it true for matrices also? No, right? This is not true for matrix because AB not equals to BA for matrix, right?
Hmm.
In general. So, but here I apply this formula. How? Actually, I apply this formula, right? Anyone? Why I able to apply this formula here? Sanchali? Think. So this is my A and this is my B.
এ মাইনাস বি এর ফলকেও যেরকম ভাঙা আছে সেরকম এবার
But
সেখানে এবার
I am saying in the last lecture, I think there is a question, right? Is this formula is true or false? There is a question, right?
হ্যাঁ
So what I say this is not true in general, right? If you take A is equals to a matrix, B is equals to some matrix, then choose in such a way such that AB is not equals to BA. Then we cannot write AB plus BA is equals to 2AB, right? If AB is not equals to BA, right?
হ্যাঁ
So this formula is not true everywhere. So similarly, I am asking,
এখানে ওই ডি স্কোয়ার যেটা আছে সেটার জন্য প্রবলেম হবে কারণ আইটা তো আইডেন্টিটি বাকিটাতে
no,
প্রবলেম
wait.
হবে
So similarly, I am asking, is this formula is true? Hmm?
এখানে বিটা তো আইডেন্টিটি বোঝাচ্ছে আইডেন্টিটি যেটার সাথে সামনে
No,
পিছু
D
সামনে
is
থেকে
D is not identity. D is not
ডি
identity.
নয় আইটা
D,
বলছি
yeah, I is identity.
হ্যাঁ এবার
So
আইটা
this
যার
formula
সাথে
is also
আমি
not true, right? This formula is not
হ্যাঁ
also not true
ওই শুধু ওই
in
থ্রি
general.
স্কোয়ার বি ওই টার্মটার জন্যই প্রবলেমটা হবে
No, the problem is actually this: AB not equals to BA. Again,
হ্যাঁ
this is
হ্যাঁ
the problem. But in this case, D into I is equals to I into D, na? Here AB is equals to BA. Here A into B is equals to B into A. So I can apply this formula. Okay. Okay. Fine. অঞ্জলি ঠিক আছে তো এবার বুঝতে পারলে তো
হ্যাঁ
কারণটা
হ্যাঁ হ্যাঁ
ওকে so now observe this so in Z3 3 is equals to 0 this 3 is equals to 0 so only we have d cube minus I cube means I cube means I right so d cube is equals to I so this is done by linear algebra but this part is not done by linear algebra this is a calculative part so I first find d square then find d cube okay this is done in the last lecture right I already told this okay now this is a very nice question so what is given see in this question given that G is finite group so G is a finite group and A is a subset of G G is finite and A is the subset of G and the cardinality of A is strictly greater than the cardinality of G by 2. Don't think the cardinality of G is even, maybe odd. So if cardinality of G is 7, then 7 by 2 means 3.5. Then what is the cardinality of A? Cardinality of A maybe 4, maybe 5, maybe 6, maybe 7 because it cannot exceed 7, right? Because A is subset of G and G has 7 elements. Okay. Then prove or disprove each element of G. So if I am saying G belongs to G is a product of two elements of A. It means G can be written as B into C, where B and C belongs to A. Okay. Is there any question till now?
না
The question is understandable, right? So I am taking any element from G and I am saying G can be written as the product of two elements B into C, where B and C both belongs to the set A. So to understand this question, okay, I discuss the proof, the solution. So see, here I take A belongs to G. So I want to prove A can be written as B into C, where B and C both belongs to the set A. So to prove this, I am defining a set B. How? B is equals to A into X inverse, where X belongs to A. Why? Because I want to prove A is equals to BC, right? Okay. If I show A into X inverse is equals to some C, where C belongs to A, then A is equals to Cx. If I able to show, then A is equals to Cx, where X belongs to A, right? So I take any arbitrary element from the group and then I show A is equals to Cx, where C belongs to A and X also belongs to A. Then the proof is done. This is my actual motive. So I am defining a set B. B is equals to A into X inverse. Now my first claim is the cardinality of this set and the cardinality of A both are same. Secondly, the A intersection B is equals to, this is non-empty, right? So I am proving the first claim. So to prove the cardinality of A is equals to cardinality of B, what I need? I need a bijective function from A to B. How? I am defining X goes to AX inverse. So I am proving this function is bijective. How? First, I need to show the function is 1, 1. 1, 1 means if the image are same, then x1 is equals to x2. So what is the meaning of f of x1? F of x1 means A into x1 inverse. What is the meaning of f of x2? It means A into x2 inverse. Now use cancellation law, left cancellation law. So then x1 inverse is equals to x2 inverse. It means x1 is equals to x2. Okay. So the function is 1, 1. Is the function is onto? Yes, the function is onto. Why? If you take small b from, if you take any element from this capital B, then show there exists an element in A whose image is B. Okay. So if B belongs to capital B, what are the elements of B? This is equals to A into X inverse, right? So B is equals to AX inverse for some X. So it will imply B is, and X inverse is equals to f of X. This is the image of X now. So observe B has a pre-image X. B has a pre-image X. It means the function is onto. So this is the process to show the cardinality of two sets are equal. If I am asking cardinality of two sets is equal, it means try to find a function, try to find a bijective function from A to B or from B to A. Okay. Otherwise, try to find a bijective function 1, 1 plus on 2. There are lots of methods, or you can take a bijective function, sorry, a 1, 1 function from A to B, and if you saying if there exists a 1, 1 function from A to B, it will imply the cardinality of B is greater than equals to the cardinality of A. And then show there exists also a 1, 1 function from B to A. So this will imply cardinality of A is greater than equals to cardinality of B. So from these two lines, you can say cardinality of A is equals to cardinality of B. Okay. There are lots of methods to show the cardinality of two sets are equal. দিদি এটা বোঝা গেছে? না এবার বলবো।
হ্যাঁ, বোঝা গেছে।
Also there is another method. So there is a lemma. If there exists a onto function from A to B, can you say whose cardinality is uh, greater than the another? It means cardinality of A is greater than equals to cardinality of B. Okay. ইশিকা বোঝা গেছে? এগুলো এক জায়গায়
হ্যাঁ,
লিখেই দেবো।
না বুঝেছি।
There are some tools to show the cardinality of two set are equal. Now I have cardinality of A and cardinality of B are same. This is the first claim. Now the second claim is the intersection is non-empty. Why? If the intersection is empty, this proof is done by contradiction, then the cardinality of this set is 0. Okay. Now what is the cardinality of the union of A and B? This is the formula, right? You can observe it by Venn diagram. So first you take the cardinality of A, then you take the cardinality of B. But observe one thing, when you add cardinality of A and cardinality of B, then the cardinality of the intersection, you add this, the intersection cardinality 2 times. So that's why I am taking minus. Okay. And from here I know cardinality of A intersection B is 0. So we have cardinality of A, and we know the cardinality of B is equals to cardinality of A. So 2 times cardinality of A. And what is the cardinality of A? This is strictly greater than cardinality of G by 2. It means cardinality of A union B is strictly greater than cardinality of G. But how this is possible? Because A and B both are subset of G. Is B is not a subset of G? Yes, B is also a subset of G, na? Because X belongs to A and A is also belongs to the group. So A into X inverse, this element also belongs to the group because G is closed under multiplication, under star operation. So this is a subset of G, na? So A is subset of G, B is also subset of G. So A union B, this is also subset of G. Then the cardinality of A union B is strictly less than equals to the cardinality of G. But here I am saying the cardinality of AB is strictly greater than cardinality of G. How this is possible? So what is wrong? This is wrong. This is wrong. So this set is non-empty. So since this set is non-empty, there exists some Y belongs to both A and B. Now Y belongs to B. It means since Y belongs to B, so Y belongs to B, it will imply Y can be written as some A into X inverse, right? Where X belongs to the set A, so from here Y belongs to A because Y belongs to A intersection B and X belongs to A. So from here I can write A is equals to Y into X, where y belongs to A and x belongs to A. See, y belongs to A intersection B, so I can write here y belongs to A also. So A can be written as the product of two elements belongs to A, right? This is a nice question, okay? This questions comes in CSR net. So that's why I'm right. This G is equals to B into C, where B and C both belongs to A. So already you learn what is the meaning of generating set. What is the meaning of uh, a group which is generated by a subset of G? Actually, this is generated by A, right? This G is generated by A. Now observe this. Given AXB is equals to CXD, it will imply AB is equals to CD. It means the X is cancelled. So this is called middle cancellation law. If middle cancellation law holds, then the group is abelian. How? I need to prove AB is equals to B, right? So what is the meaning of this line? This is equals to B, right? And here this is also equals to B. Okay. So now cancel A inverse from the both side. By middle cancellation law. Then I will get AB is equals to BA. So done. Okay. This is a very important question. The cardinality of G is finite. It means the group is a finite group. Okay. It means the group is finite group. So if the group is finite, then I am asking what is the cardinality? If I am asking how many elements of order 2 will be present in the group. Ishika, how many elements are present in the group G? Can you say? Are you there? What is my question? Oh, there are lots of things. Order of G is finite. So I am asking, do you know what is the, okay, wait. First see these things. This question. Take those matrices whose all the entries are same. Now, which of the following is true? This is a group or not? Is it a abelian group or not? Under usual addition, under multiplication. Okay, multiplication means matrix multiplication. So this is a group under multiplication, and this is a group. This is a abelian group. How? Sanjaledi, how? I did it for 2 by 2 matrices. So do it for n by n matrices. If you take any two elements from G, then the element A is say A is equals to this matrix, B is equals to this matrix. If you multiply A into B, then you will see AB is equals to this matrix. And this is equals to BA also. Okay, so G is abelian. Okay, okay, observe one thing. My question is, this set is group under, this set is an abelian group under usual matrix multiplication. So first show G is non-empty. Why G is non-empty? Because 1 1 1 1, this element belongs to G, so G is non-empty. Okay, then I will show G is closed under matrix multiplication. So take any two elements from G, show that AB into B, this is also belongs to G, right? So here in this question I take n is equals to 2. So if I take n is equals to 2, take A matrix and B matrix, then I multiply A into B, I get 2AB, 2AB, 2AB. So this 2AB, here also 2AB, here also 2AB, here also 2AB, here also 2AB. It means, and all the entries are non-zero, A and B is, because A and B are non-zero, so then 2AB is also not equals to 0. In this question, A belongs to R star. This is important. A belongs to R star. So this AB belongs to the group G, actually belongs to the set G, because I am proving this is a group, right? Also, I write AB is equals to BA here. Okay, so this is first of all, this is closed under matrix multiplication. This set is non-empty. Now I want, is the set is associative with respect to matrix multiplication? Yes, matrix multiplication itself is associative. So I want to say A into B into C. This is equals to AB into C, right? So you can take any matrix AB. So if you choose a particular type of matrix, this kind of matrix, then this is also true. So this set is associative with respect to the given operation. Okay. Now I want to find, is there exists the identity element? Yes. Actually, I need AB AB is equals to BA is equals to A, right? For which B this holds. Okay. So if I multiply, then I will get this. Okay. Now I need AB is equals to A, and AB is this, A is this. When two matrices are equal, if the order are same and corresponding entries are same, so from here I have 2AB is equals to A, so it means B is equals to half. Okay. So the identity matrix, sorry, so the identity element of G is half, 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 half. So here for this set, the identity element is this matrix, not this matrix. Okay, because this element does not belongs to G. Why? Because all the entries are not equal. Okay, identity element must belong to the group, right? So this E belongs to the group, and if you multiply, if A into E is equals to E into A is equals to A, so that's why E is the identity element for this G. Now I want to find the inverse of any element. if you have A and B, if you want to find B, it means I want to find A inverse. So I want AB is equals to E. I want to know what is B. Okay. So AB means this and E is this. So from here I can say B2AB is equals to half. It will imply B is equals to 1 by 4A. Since A is not equals to 0, so B will exist. So what is the inverse of A? The inverse of A is 1 by 4A, 1 by 4A, 1 by 4A. So I did it for 2 by 2. So in general, for n by n order matrix, E is 1 by n, 1 by n, 1 by n. These are n by n order matrix. And what is the inverse of A? This is 1 by n square A, 1 by n square A, 1 by n square A, 1 by n square A. Okay. So this G is a group with respect to usual matrix multiplication. But this is not the identity element of this group because this does not belongs to G. Okay. And second thing, this G is not a group with respect to matrix addition. Why? Because the identity element 0 does not belongs to G. Identity element means zero matrix. Okay. Zero matrix does not belongs to the group. Why? Because A belongs to R star. If you add A belongs to R, then this will form a group with respect to addition also. Okay. So this is also a nice example. Now, what is finite group? If G has finite number of elements, or I can say G is isomorphic to Jn for some n. Okay, it means the cardinality of G is n. Otherwise, the group is called infinite group. It may be the order of the group may be countable, may be uncountable. Okay, so these are the examples of finite group. Till now, you know about Zn, Un. Okay, you have no idea about Dn, Sn, Q8 till now. And these are the group of infinite order. Mn over R, GLN over R plus, R star dot. Okay. So because the order of this set is not finite, right? Sanchalidhi, this set is not finite. GLNR, this is not finite. R is not finite. R star is not finite. So all the group is of infinite order. So what is order? Order is the cardinality of the group. Okay. Order is the cardinality of the group. What is the order of an element? If you take an element from G, then I am asking what is the order of A? If there exists n, that is the least positive integer such that A to the power n is identity, then n is called the order of A. Okay. So n is the least positive integer such that A to the power n is equals to identity element. And what is the meaning of A to the power n? A to the power n means A into A into A n times. Okay. Huh. Okay, done. So in this question, if 1 belongs to Z, then what is the order of 1? Order of 1 is infinite. What is the so here observe, if there does not exist any n such that a to the power n is identity, then the order of a is infinite. It means no such n exists for which a to the power n is equals to identity, then the order of a is infinite. So in this, if I take 1 belongs to Z, then what is the order of 1? Order of 1 is infinite. Why? Because 1 to the power k is equals to 1 plus 1 plus 1 k times. Okay, so 1 to the power k means k. This is not equals to 0 for any k. So that's why order of 1 is infinite. 1 belongs to Zn. What is the order of 1? Order of 1 is n. Okay, because 1 plus 1 plus 1 is equals to 0. If you add n times, okay, n is the least positive integer. If you take any k which is belongs to 0 to n, then 1 to the power k is equals to k, which is not equals to 0 in Zn, right? So in this question, U10 is this 1, 3, 7, 9. What is U10? Sanjalidi? Those elements from Zn whose GCD, which is prime, relatively prime to 10. So it means GCD of a
10 এর থেকে
comma
ছোট যে
10 is
সমস্ত
equal.
নাম্বার গুলো হবে।
Yes, yes. Whose GCD with 10 is 1. So GCD 1,
ওয়ানটা কি
3,
আসবে?
7, 9. These are the elements of U10. So I am asking what is the order of 1?
ওয়ানটা ওয়ানটা হবে?
Order of, yes, GCD of 1 comma 10 is what? 1 na?
ওয়ানটা তো
Okay.
প্রাইম নিয়ে কোনো নাম্বারই না, ওটা কি আসবে?
No. What is the GCD of 1 and 10? What is even?
না, 10 এর থেকে
I am
ছোট যে
asking.
সমস্ত প্রাইম নাম্বার,
Okay, wait. What is even? Say.
n এর থেকে ছোট যে সমস্ত প্রাইম নাম্বার আছে,
What is U10? It means x belongs to natural number such that GCD of x comma 10 is equals to 1. GCD of x comma 10 is equals to 1, and x is greater than equals to 1 and less than equals to 10. Okay, fine.
মানে ওগুলো প্রাইম হতে হবে বা কিছু সেরকম ব্যাপার
No,
না।
no, 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 no.
আচ্ছা আচ্ছা,
I say relatively prime. Relatively prime.
ও
Relatively
আচ্ছা,
prime means GCD is equals to 1.
তাহলে ঠিক আছে।
So now what is the order of 1? 1 to the power 1 is, because 1 is the identity element of this group. So 1 to the power 1 is 1, and the order of identity is always 1. Okay, remember this. So 3, what is the order of 3? 3 square is 9. This is not equals to 1 in U10. Okay, in Z10. 3 cube, it means 9 into 3. Okay, it means 27. So in Z10, 27 means 7. So this is also not equals to 1. 3 to the power 4. So 3 cube into 3. And what is 3 cube? 3 cube is 7. So 7 into 3. It means 21. And 21 is equals to 1 in Z10, right? So what is
হ্যাঁ,
the order of 3? So order of 3 is 4. Because 4 is the least positive integer, right? So similarly do it. Okay. So now wait. Ishika, where is your question? Uh, prove that the set T of all odd integers forms a commutative group with respect to star defined by A star B is equals to A plus B minus 1 for all AB belongs to D. Find inverse of 3. Okay. So what is the set D? Set of all odd integers. So D is equals to 2n minus 1 or plus 1 for all n belongs to Z. Okay. This is your D set. So the question is D star, is it a group? This is the actual question, right? Is this a abelian group? So see, 1 belongs to D because 1 is odd. It will imply D is non-empty. So first of all, you need to show D is non-empty. Okay. Second, take any two odd numbers. So say A, comma B belongs to D. Since A is odd, it will imply A can be written like this and B can be written like this for some n1, comma n2 belongs to Z. Now, what is A star B? A star B is A plus B minus 1. This operation is given, na? So A plus B means 2n1 minus 1 plus 2n2 minus 1 and minus 1. So here we have 2 into n1 plus n2 minus 1. If you add these two and again minus 1, right? So take n3 is equals to n1 plus n2 minus 1. This is also belongs to Z, right? So it will imply A star B belongs to D. So D star is closed. Okay. This is the first thing, non-empty. This is the second thing, closed. Now, associative property holds A star B star C. I am giving you, this is an exercise. Show that. Okay. What is the identity? What is the identity element? So for identity, I need A star B is equals to B star A is equals to A. This is true for all AB. Oh, sorry, this is true for all A belongs to D. I need B, right? For which B this holds. Okay. So A star B is equals to A. It means A plus B minus 1 is equals to A. It will imply B is equals to 1. And similarly, from here also you will get B is equals to 1. So 1 is the identity, okay? You need to show it for the both sides. So this is identity. Now, what is the inverse? So B is equals to 1. This is the identity element. This is the identity element. What is the inverse element of A? Inverse of A. So I need B is equals to 1, right? Since 1 is the identity element. So now A plus and B star A, this is also equals to 1. So from here B is equals to 2 minus A. Okay. So that's why D and observe commutativity. Commutativity. A star B is equals to A plus B minus 1 is equals to B plus A minus 1 is equals to B star A. Okay. So D star is a commutative group. 1 is the identity. And the inverse of A is 2 minus A. Okay. So now the second part is, what is the inverse of 3? The inverse of 3 is 2 minus 3 equals to minus 1. Okay. Done. So write it properly. Okay. Now one question is left. So till now we have what is the order of a group and what is the order of an element. Okay. Now I am asking, if the order is finite, Isika, if the order is finite, then how many elements of order 2 will be present in the group G? Is it even? Is it odd? This is my question.
Order 2.
How many elements of order 2? Okay. Can you say me? Is it a, did you show that this set is non-empty?
Hmm.
Okay, correct. Okay. Hmm? সঞ্চালি দি পারবে না? মিউট আছে। আইডিয়া আসছে না?
No.
Okay. First solve this question. Then I will ask it again. So here the order of the group is finite. A is a set. Is the collection of those elements whose cube is equals to identity. What is the meaning? X cube is equals to identity means order of X is either 1 or 3. Okay. Till now we didn't know about the property of orders. So what is the cardinality of A? Cardinality of A is odd. How? Cardinality of A is odd. How? So see, x cube is equals to identity. So there is two possibility. X may be identity or x may not be identity. Okay. If x is not identity and x cube is equals to identity, this is given. So x inverse cube, it is also identity. Why? Because x inverse into x inverse into x inverse. Now use Shoksu property. Okay. So from here I can write x cube its inverse, and x cube is identity. This is given. So inverse is identity. So observe one thing. If x cube is identity, then x inverse its cube is also identity. Okay. Now my question is, for x, I have x inverse also, right? Another element. Acha, is it true or false? X is equals to x inverse. Is it true or false? No, right? If x is equals to x inverse, then x square is equals to identity. Now operate x in both sides. Then x cube is equals to x, and see, x cube is equals to identity here. So it means x is equals to identity. But in this case, I choose x is not equals to identity. So x is not equals to x inverse. Okay, x is not equals to x inverse. So I have a pair x comma x inverse. So how many elements are there where x is not equals to identity? There are even number of elements, right? There are even number of elements, because if x comes, then x inverse cube, it's also identity, and they are not equal. So even number of elements are there, and since if x is equals to identity, then e cube is equals to identity. It means e also comes. So there are odd number of elements. From here I will get even number of elements, and for this I will get one extra element. So there are odd number of elements. Okay. Okay, done. অঞ্জলিদি ঠিক আছে, এবার বুঝতে পেরেছো?
হ্যাঁ।
আচ্ছা, so now do this question. X square is not equals to identity. So there are even number of elements. Why? Since x square is not equals to identity, it means x is not equals to x inverse. Okay. Observe one thing. Identity element does not belong to the set. Okay. So now, if x belongs to the set B, then x square is not equals to identity. Observe one thing. If x belongs to B, it will imply x inverse this will also belongs to B. Why? So x inverse it is square, it means x square its inverse. This is not equals to identity. Why? Because if x square its inverse is equals to identity, then take inverse in the both side, then x square is equals to identity. This is contradiction because x belongs to B. Okay. So if x belongs to B, then x inverse also belongs to B. So this comes in pair, right? Why? The pair contains two distinct elements, right? Two distinct elements, because x not equals to x inverse. Here, observe. So the cardinality of B is even. Okay. Now I am asking, if G is a finite group, then uh, how many elements are there of order 2? Even, second, odd. If the cardinality of G is even, the answer will be odd. And if the cardinality is odd, then the answer is even. Why? See, there is a theorem, Lagrange theorem, and its corollary, order of A, order of any element will divide order of the group. So 2 does not divide any odd number. So if the order is odd, then there exists no element of order 2. Okay, and 0 is even number. Done. And if the order of the group is even, there is a theorem called Cauchy theorem. Since 2 is prime, Cauchy theorem tells us any prime number which divides the order of the group, then there exists an element A, say A, whose order is P. Okay. So since 2 divides an even number, so it will imply there exists at least one element. Okay. So how many elements are there whose square is not equals to identity? Even number of elements are there. So cardinality of G is even. Cardinality of G is even. Minus cardinality of B. It means order of X is strictly greater than 2, na? X square is not equals to identity means order of X is greater than 2. Okay. So even minus even is even. So this set contains identity element and all the elements of order 2, because E square is equals to E, right? Actually, this is the cardinality of B complement. Okay. Since order of identity is 1, so even minus 1 element means odd number of elements. So there are odd number of elements of order 2. Okay, I'll tell it in the future lecture, but I think this rough idea is enough to solve your query. Okay, done? Fine, Anjali, stopping here.